my dear PU1 students, so your unit test is round the corner and I'm very sure that many of you might be confused about how to prepare, what to focus on, might be feeling pressurized. Don't worry, I have got you back. So in this video, we are going to discuss some of the most important and frequently asked questions that will help you to score high in the test in less time preparation, right? And remember, all of these questions are hand-picked and exam relevant. Okay, so and here's something fun also. So at the end of the session, I have one challenging question for all of you and you need to drop the answers in the comment section and let me see who gets it right. Okay, so grab your notebook, get focused, and let's dive into the most important questions for unit test 1 of PU1 students. Okay, so here's the content for this particular video. So we have 3 chapters. I have taken this syllabus based on the syllabus that was given for North Bangalore. Okay, so what were the chapters given here? Some basic concepts of chemistry. So here I have taken 5 MCQs, 5 FIB, 2 marker questions 5, 3 marker questions 3, and numerical questions 4. Okay, and the total number of questions comes out to be 22 here. Next chapter was classification of elements and periodicity and properties. So here MCQ 5, fill in the blanks 5, 2 marker questions 5, then we have 3 marker questions 3, so total number of questions is 18. And then we have some basic principles and techniques. So here it is up to hyperconjugation. Okay, up to hyperconjugation. So here I have 5 MCQs, 5 fill in the blanks, 5 2 marker questions and 3 3 marker questions. A total of 18 questions are there. Okay, so if I add total almost 58 questions, so roughly 60 questions you are going to practice with me for these 3 chapters, and that will definitely help you to boost your confidence and increase your practice also. Okay, so one more thing that I want to say here is if you have any different syllabus for unit test 1, do comment down. I'll try to make a video on that also. If you are not having these 3 chapters or some other chapter is there, please let me know in the comment section. Okay, this one is according to the North Bangalore syllabus. Okay, so moving on to the first chapter, that is some basic concepts of chemistry, a very important chapter and very fundamental chapter for the whole chemistry, I can say, to study. So here we will go with the first question, that is from the applications part. The patient suffering from AIDS can be helped using which of the following drugs? So is it cisplatin, is it AZT, is it Taxol, it is codeine? So can you answer? If you know the answer, please put down, pause the video and put the answer in the comment section. Okay, so I'll tell the answer here. So the answer for this question is your AZT, that is called as azithromycin. Okay, moving to the second question here, what are the basic constituents of matter? This is again very simple question. You have atoms and molecules, atoms and moles, molecules and ions, nuclei and ions. So we know that all matter is made up of fundamental particles called as atoms, and when we have more than one type of atoms combined in a fixed ratio, we call it molecules. So all matter are made up of atoms and molecules. Moving to the third question here, the substances whose compositions are not uniform and different components are mixed are called as. So the composition is not uniform. So we have heterogeneous mixture and homogeneous mixture. So homogeneous mixtures are those where the components have a uniform distribution, but here they have non-uniform distribution and different components. So that is why it is heterogeneous substance. That is option number B here. Next we have dash is made up of 2 or more pure substances which may be in any ratio. So when it is given any ratio, means it is not fixed ratio. If it is not fixed ratio, then it cannot be compound or molecule. Okay, so it has to be mixture. Element does not have more than one atom. Molecule have more than one atom, but it is in a fixed ratio, not in any ratio. And atoms also do not have more than one mix of 2 atoms. Okay, so it is option number A, that is mixture. Next, which of the following is not a pure substance? So copper is a pure substance, gold is a pure substance, sugar solution is made up of sugar and water. Okay, and water is made up of hydrogen and oxygen. So this is also pure substance, this is also pure substance, but this cannot be considered as a pure substance because it is a mixture of two things and does not have any fixed ratio also. Okay, so that is why sugar solution. Now moving to fill in the blanks. So in fill in the blanks type questions, you will be having you will be given with certain words that you need to fill in the given fill in the blanks questions. So question number 1 here is, when all the constituent particles of a substance are same in the chemical nature, it is said to be. Okay, so when you have all the constituent particles of a substance are same in chemical nature, it is said to be. Is it Kg per meter cube? No. Avogadro constant? No. Coordination entities? No. Weight? No. Compound? No. When all the constituents of a substance are same in the chemical nature, it is called as a pure, or it is said to be pure substance. Okay, so answer here is pure substance. Okay. Next, when two or more atoms of a different elements combine together in a definite ratio or in a fixed ratio, that gives you something called as compound. So this is my compound. Okay. Next we have the force exerted by gravity on an object is called as weight. Okay, the force is the difference between mass and weight. So when the gravity, the force, the gravity that is exerted on a certain particle, that is its weight. Okay. Next, the SI unit of density is kg per meter cube, and then the number of entities in 1 mole is your Avogadro constant. Okay, yeah, Avogadro constant. I hope this is clear. Very simple fill in the blanks questions. Now let's move to 2-marker question. What is a homogeneous mixture? Give an example. Now this question is very simple. How you have to answer it? First, you have to define what is a homogeneous mixture, and then you have to give an example. So homogeneous mixture, as we know, is any solution which is having uniform distribution throughout the solution. You cannot separate solute and solvent in a homogeneous mixture. Okay, so let's see here what is the answer. A homogeneous mixture is a mixture in which the components are uniformly distributed and cannot be seen separately. You cannot visualize, suppose you have made sugar and salt dissolved in water. You cannot find salt in that. It is uniformly distributed in the solution. Okay, and the composition is same throughout. So here this is homogeneous mixture, and the example is salt solution or sugar solution. Next we have state the law of conservation mass and law of definite proportion. Now you have 2 laws, so each law will carry 1 mark. So you have to define law of conservation of mass, that is 1 mark, law of definite proportion, that is 1 mark. So what is law of conservation mass? Law of conservation of mass says that mass can neither be created nor be destroyed. Okay, or whatever is the mass before the reaction, same is the mass after the reaction. And what is law of definite proportion? Law of definite proportion states that when two atoms, when you have a certain compound, irrespective of the sources, the elements combine in a fixed ratio to give you a compound. Okay, irrespective of the source. Like for example, if you consider water, water always combines in a ratio of 2:1, means 2 hydrogen atom and 1 oxygen atom. Whether you derive that water from rain or from tap water, groundwater, every source, irrespective of the source, the composition of the water remains constant. That is law of definite proportion. Okay, so let's see here. Law of conservation of mass states that mass can neither be created nor destroyed in a chemical reaction. The total mass of the reactants is equal to the total mass of the products. Okay. Next, law of definite proportion. A given compound always contains the same elements combined in a fixed ratio by mass, regardless of its source or method of preparation. Regardless of the source or method of preparation, a given compound always contains the same elements in a fixed ratio. Okay, as I give an example, if you take water from any source, it will always contain hydrogen and oxygen in a fixed ratio. Okay, moving to the third question here, what is Avogadro's constant and how do you denote Avogadro number? Again, this is a 2-mark question. So when you define what is Avogadro constant, that is 1 mark, and how do you denote Avogadro number, that is your second question, or 1 mark you will get from there. So what is Avogadro constant? Avogadro constant is the number of particles present in 1 mole of a substance, and its value is 6.022 into 10 to the power of 23. How do we denote it? You denote it using capital N and a subscript of A, or sometimes capital N and subscript of O, but generally it is NA. Okay. So you can see here, Avogadro constant is the number of particles. This number of particles can be atoms, molecules or ions, okay, present in 1 mole of a substance. And how do we denote it? We denote it, so I'll just take this part, we denote it using Na, okay. Na is the correct way of representation, and what is its value? 6.022 into 10 to the power of 23 particles per mole. Clear? Moving to the fourth question here, what is the empirical formula for the following? Fructose and caffeine. Okay, so what is empirical formula? So empirical formula and molecular formula are 2 different things. Let me explain you. Okay, so let's understand this one. I have empirical formula and molecular formula. So molecular formula, okay, molecular formula tells you the exact number of atoms of each element in a molecule. Okay, exact number of atoms of each element in a molecule, that is called as molecular formula. And next we have empirical formula. Empirical formula, it is the ratio of atoms of each element in a molecule. Okay, now I'll tell you the difference also. Okay, let's talk about one compound, that is glucose. Okay, what is the formula of glucose? That is C6H12O6. Now what information this gives you? This tells you that in the glucose molecule there are 6 carbon, 12 hydrogen and 6 oxygen, right? So this is the exact number of atoms of each element present in the molecule. Now empirical formula tells you the ratio. So if I write carbon, hydrogen, oxygen, 6 carbons, 12 hydrogen, 6 oxygen, what is the ratio of this one? 1:2:1. So the empirical formula will be CH2O, which tells you the ratio of the atoms present in the molecule or in the compound. I hope you got the difference. So if molecular formula is given and you have to find the empirical formula, you just have to cancel each of the, like if there is any number by which all of them can be divided, so just divide it and find the simplest ratio that is possible in between the atoms. Okay, now let's go back to our question. You have C6H12O6, which I have already defined, CH2O, and then we have C8H10, so C8H10 N4O2. Okay, so I have carbon, hydrogen, nitrogen and oxygen. So 8, 10, 4 and 2. So is there any number by which all of them are divisible? Yes, by 2 I can divide all the numbers. So 2 4s are 8, 2 5s are 10, 2 2s are 4, 2 1s are 2. Right? Is there any number now by which all of them are divisible except 1? No, I cannot find any other number by which all of them can be divisible. So what is my empirical formula here? It will become C4H5O2, C4H5N2O. Okay, so that is the I can say that is the caffeine's empirical formula. Clear? Now let's see. So this is for fructose and this is for caffeine. Moving to the fifth question of 2 marker section, define molarity, write its mathematical expression. Okay, so molarity is what? Molarity is a unit or is a way of representing concentration. How much solute is dissolved in a solution or how much solute is present in a solution. To represent that, we use the term molarity. Okay, so now how do we define molarity? Molarity is the number of moles of the solute present in 1 liter of the solution. Okay, so what is molarity? Molarity is number of moles of the solute dissolved in 1 liter of the solution. Now how do we represent its mathematical expression? So molarity is equal to number of moles of the solute into 1000 divided by the volume of the solution in ml. Okay, here I want to modify certain this formula so that you can understand it better. So molarity is denoted, how it is denoted? It is denoted with capital M. Okay, so now molarity will be equal to, I have written number of moles of the solute. Now what is number of moles? Given mass of the solute, given mass of solute divided by molar mass of solute okay, this is what? This itself is number of moles. Clear? Then into 1000 by volume of solution in ml. Clear? This is fine. Now coming to this part, that is, if the volume is given in liter, you don't have to multiply this 1000. Okay, it is only required when the volume of the solution is in ml. Now let me tell you something. Suppose I tell you that a solution is 5 molar NaCl solution is taken. What does this indicate? Because this is very important when you solve numericals, you have to understand this. When I say this one, this says that 5 moles of NaCl is present in 1 liter of solution. Okay, that is the meaning or the physical significance of this particular expression. Clear? Let's move to now 3 marker question. Mention the SI unit of electric current, thermodynamic temperature and amount of substance. So electric current unit is ampere, temperature is Kelvin and amount of substance is moles. Okay, so this is the name and the symbol, both you should be knowing. Moving to the second question here, write any 3 postulates of Dalton's atomic theory. This is very important question, a very frequently asked question, also very easy to remember. Any 3 postulates you can remember. Okay, so I'll give you 3 postulates here. All matter is made up of indivisible particles called as atoms. Second, atoms of the same element are identical in mass and properties. Third, atoms combine in simple whole number ratios to form compounds. Okay, so these are 3 postulates. There are other postulates also, you can remember that also. Okay, now moving to the next question, what is mole fraction? Write its mathematical expression for a substance A dissolved in substance B and their number of moles are Na and Nb respectively. Okay, so what is mole fraction? Mole fraction means, suppose we have 2 substances. Okay, suppose you have in this container, you have particles of A, you have particles of B. Okay, so what is mole fraction? Number of moles of A. Suppose you want to find out the mole fraction of A, that is equal to number of moles of A divided by the total number of moles. Okay, so now if I show that here, so how will you define mole fraction? Mole fraction is the ratio of number of moles of a component to the total number of moles of all the components in the solution. Now mathematical expression here will be Na is equal to Na plus Na divided by Na plus Nb, where Na is the number of moles of substance A, Nb is the number of moles of substance B here. Okay. Fine. With this, we'll go to now some numerical questions also. Okay, this is very important question. Again, you will be given certain similar questions in the exam as well. A compound contains 4.07% of hydrogen, 24.27% of carbon, 71.65% of chlorine. Its molar mass is 98.96 gram. What are its empirical formulas and molecular formula? Okay, so how to do this? So I'll tell you how to do this. Let me first explain it. So first of all, you will have to make a table. Okay, so here you should be writing element name. Okay, here the percentage, whatever percentage is given. Then here you should be calculating number of moles. Okay, and here it should have simple ratio. Now elements and percentage will be given to you in the question. How will you calculate number of moles? The percentage divided by the molar mass, right? So what is number of moles? The percentage divided by the molar mass. Okay, how to find simple ratio? This is also very simple. Now whatever numbers you have got, suppose 3 elements are there, 4 elements are there, you will get 4 numbers here. Whichever is smallest out of that number should be divided by all the numbers. Like for example, suppose you have got 4, 2, 6, 8. Okay, these numbers. Now which is the smallest number out of this 4? 2 is the smallest number, right? So every number has to be divided with 2. So here 4 divided by 2, you will get 2. 2 divided by 2 will get 1, 6 divided 2 by 3, 8 divided by 2 will be 4, right? So now suppose this is element A, this is element B, C, D. Okay, so what will be the formula now? You have A2, right? You got A2, B1, C3 and D4. Okay, so this is your this is your empirical formula. Okay, got it, this one? First we will write the elements name, their percentage, you will calculate the number of moles, and then you will divide the number of moles with the molar mass to get the numbers here. Then whatever we get, this number of moles, you have to divide the smallest one with all of them to get the simple ratio, and then we'll get the molecular formula. After that, then we will get the empirical formula. After we get empirical formula, you have to calculate empirical formula mass. Okay, now let me take certain examples. Suppose the empirical formula we got is CH2O. Then what is the empirical formula mass? Just you have to add the masses of them. So 12 plus 2, 14, 14 plus 16 I'll do, that is 30. Okay, this is empirical formula mass. Now you will be given with molecular mass in the question. For example, the molecular mass is 60. Okay, just example, molecular mass is 60. Empirical formula you calculated using this table. From empirical formula we can calculate empirical formula mass. Molecular mass will be given to you in the question. After that, what you have to find? You have to find something called as N value. What is N value? N value is molecular mass divided by empirical formula mass. 60 divided by 30, that is equal to 2. Okay, so this we got the value as 2. Now what we have to calculate? We have to calculate molecular formula is equal to empirical formula into N. So what is empirical formula? CH2O into 2. What is N here? That is 2. So if I multiply C2H4O2, C2H4O2, that is the empirical formula. This is the molecular formula. Okay, so what I have done, first using this table we have to find empirical formula, then using this empirical formula we have to calculate empirical formula mass, then you have to find the value of N. How will you find the value of N? Molecular mass divided by empirical formula mass. Okay, that will give you N. Then molecular formula will be equal to empirical formula into N. Okay, so let me just summarize this, you can note it down. Okay, so first step is to find empirical formula. Second step is to find empirical formula mass. Third step is to find the value of N by dividing molecular mass by empirical formula mass. And the fourth formula is to find molecular formula, empirical formula into N value. Okay, so this is the steps. Okay, so now we will be solving this question using this step. So what is given to me in the question? hydrogen percentage, carbon percentage, chlorine percentage, and the molar mass is given. So first we have to do the table. Okay, so this table I have already done for you. You will just check now here. So percentage, hydrogen is given 4.07, carbon is given 24.27, chlorine is 71.65%. Now how do we find number of moles? Percentage divided by molar mass, right? Or yeah, so 4.07 I'll do here what? Divided by 1. Why? Hydrogen mass is 1, so I'll get 4.07. For carbon it will be divided by 12 because carbon molar mass is 12. If I divide, I'll get 2.0225. Next, for chlorine I'll divide by 35.5. I'll get 2.0176. Now which is the lowest of all this? This is the lowest of all this, right? So each of these numbers has to be divided by 2. So now 4 divided by 2, roughly I'll get 2. This is 2 divided by 2, 1. This also I'll get 2 divided by 2, 1. So what is my empirical formula now? Empirical formula will become CH2Cl. Okay, this is my empirical formula. What was the next step to calculate the empirical formula mass? If I add these two, carbon is how much? 1 second, yes. Carbon is okay. So carbon is 12, hydrogen is 2 plus 35.5 is chlorine. So if I add this, I'll get empirical formula mass is 49.5. Okay. Now after this I have to calculate the N value. N value is molecular mass by empirical formula mass. Molecular mass is 98.96. Empirical formula mass is 49.5. And if I divide this, I'll get 2. Okay. So this is your N value. Now how to find molecular formula? Molecular formula is equal to empirical formula into N. Okay. So what is empirical formula? CH2Cl into 2, so that will give me C2H4Cl2. That is your molecular formula. So what was the question asked? What are its empirical and molecular formula? So empirical formula is CH2Cl, molecular formula is C2H4Cl2. Okay, I hope this is clear. Next, calculate the amount of water produced by the combustion of 16 gram of methane. Okay, so this is from the stoichiometry. So the step 1 is what? Step 1 is to write a balanced equation here. Okay, balanced equation. Okay, so first we have to write the combustion of methane. So CH4 plus O2 gives CO2 plus H2O. Okay, so I can see any difference. How can I balance it? So there are 4 hydrogens, so I'll make this 2. Then I think I have to make this 2. Okay, now the reaction is balanced. Now what is this? This is 1 mole of methane. Okay, 1 mole of methane is giving you 2 moles of water. Okay, if I convert it into mass, so I can say 1 mole of methane means 16 grams, right? 16 grams is giving me 2 moles of water, that means 2 into 18, because 18 is the molar mass of water, that is 36 grams. So 16 grams of methane, or I can say 1 mole of methane will produce 36 gram of water. Clear? Okay, next we'll move to, so how will you write it? So see, so you can write like this: CH4 plus 2O2, okay, gives CO2 plus 2H2O. Now what you have to write? 1 mole of methane, 1 mole of methane gives 2 moles of water. Okay, then I can say, here you can write 1 mole of methane is equal to 16 grams. Okay, so I can write 16 gram of methane gives 2 moles of water. Okay, then you can write down 2 moles of H2O is equal to 36 gram. So I can write 16 gram of methane gives 36 gram of water. Okay, that has to be the final answer. Moving to the third question here, a solution is prepared by adding 2 gram of substance A to 18 gram of water. Calculate the mass percentage of the solute. Okay, what's the formula for mass percentage? Mass percentage is equal to mass of the solute by mass of solution into 100. Okay, so what is mass of the solute? 2 gram. What is mass of the solution? 2 gram plus 18 grams, so that is total 20 gram into 100. Okay, so that gives me around 10%. Okay, so mass percentage is 10%. Clear? Very simple. Move to question number 4. Calculate the molarity of NaOH in the solution prepared by dissolving 4 gram in enough water to form 250 ml of the solution. So let's write down mass of the solute is how much? Mass of solute is 4 gram. What is solute here? NaOH. Yeah, so NaOH is the solute, right? So mass of NaOH is 4 gram. What is the molar mass of the solute? Molar mass of NaOH is equal to, if you add this, how much I'll get? 23 is for sodium, 16 plus 1. So that gives me 40 grams. 40 grams per mole. Okay, that is the molar mass of the solute. Now what I have in the molarity? Molarity is equal to, I have here given mass. I'll write the formula, given mass by molar mass into 1000 by volume of the solution in ml. Okay, so what is the given mass? Here given mass is 4 grams, molar mass is 40 grams into 1000 by, what is the volume? 250. Okay, so I'll get 0.4 molar. Clear? So now let us see the 5th question. This question is slightly tricky one. So now see, the density of, the density of 3 molar solution of NaCl is 1.25 gram per ml. Calculate the molality of the solution. Okay, so this question is very tricky one, and you have to understand some basics. So first I'll tell you how we have to approach it, the process, then I'll show you the solution. Okay, so now here you see we have certain things to remember. 3m solution of NaCl, what does that mean? Now 3m means that I have 3 moles of NaCl, right, in 1 liter of solution. Clear? This is the meaning of 3 mole NaCl. So from this, what all things, from this one line, what all information I can derive? So from this I can get number of moles of solute, right? Number of moles of solute is how much? 3 moles. I can calculate mass of the solute. Mass of solute. So mass is what? 3 moles into NaCl mass is 23 plus 35.5, so that means 58.5, right? So you will get the number of moles of solute is already given. We can convert it into mass of the solute, and I have volume of the solution. Okay, volume of solution, that is equal to 1 liter. I have density of the solution given in the question. Density of solution, which is equal to 1.25 gram per ml, right? This I can write 1 liter equal to 1000 ml. Okay, now the question is asked us to calculate the molality. Okay, so these are the given information, hidden given information. From this one line, okay, 3 moles of NaCl in, or 3 molar solution of NaCl, we have found out the number of moles of NaCl, mass of NaCl, the volume of the solution, density is also given to us. Now what is the question asked to you? Molality. How to calculate molality? Number of moles of the solute into 1000 by mass of the solvent. How to do that? Mass of the solvent. How can we find mass of the solvent? So let's see here. See, you have got mass of the solute. we have got density of the solution and volume of the solution. Using these two data, can I calculate mass of the solution? Can I calculate mass of the solution? Yes. Why, ma'am? Density is equal to mass by volume. I have been given with density and volume. I'll calculate mass of the solution. I have mass of the solute. Using this one and this one, total mass of the solution, I'll get 1250. Mass of the solute is this much. If I multiply, what I'll get, that is the mass of the solute. Now, mass of the solution is there, mass of the solute is there. If I subtract, I'll get mass of the solvent from here. Let me revise this question. Let me explain you once again. This is very tricky question. You have 3 molar solution of NaCl. That means 3 moles of NaCl in 1 liter of the solution. You have moles of the solute 3. Molar mass of the solute 3 into 58.5, volume of the solution 1 liter or 1000 ml, density of the solution is 1.25 gram per ml. If I take now volume and density, I can get mass of the solution. I have mass of the solute. If I subtract these two, I will get mass of the solvent. Next, you have number of moles, mass of the solvent into 1000. If you do, you can calculate molality. Right? I hope all the step is clear. So what is my first step? To calculate the mass of the solute. What is my second step? To calculate the mass of the solution. What is my third step here? Third step is to calculate mass of solvent. Okay, this is my third step. And the fourth step is to calculate the molality. First step, to calculate the mass of the solute. Second step, mass of the solution. Third step, mass of the solvent. Fourth step is to calculate molality. Okay, so I'll show you now the solution, how we can do. Okay, so what is the data given to you? Molarity, molarity is 3 moles per liter. Density is 1.25 gram per ml, and molar mass of NaCl that I can calculate is 58.5 gram per mole. So okay, now I'll go for mass of the solution. To calculate the mass of the solution, very simple. We have density into volume. Now, as I told you, 3 moles means what? 3 moles in 1 liter, right? So, what is the volume of the solution? 1000 ml. Density is 1.25. So, mass of the solution is 1250 gram. Next is mass of the solute. So, moles into molar mass. Moles is 3 moles. Molar mass is 58.5 gram. If I multiply, 175.5 gram. I got mass of the solution. I got mass of the solute. Next is to calculate mass of the solvent. 1250 minus 175.5, that will give me 1074.5 grams. Okay, so I got now mass of the solution, solute and solvent. So this is what is of importance for me to calculate the molality. Next, if I go for molality, what's the formula? Number of moles into 1000 by mass of the solvent in grams. So what is my number of moles? Number of moles is 3000, mass of the solvent is 1074.5, and if I solve this, you will get molality of 2.8 molal. Okay, so that is the solution for this question. A little bit tricky one, but yes, you can solve this. Moving to the 6th question here, the density, this is also similar question but in a reverse way. Okay, the density of a 3 molar solution of NaOH is 1.11 gram per ml. Calculate the molarity of the solution. So this time it is reversed. We have been given with what? 3 molar. That means 3 moles in 1 kg or 1000 gram solvent. Right, this is the number of moles of the solute in 1 kg or 1000 gram solvent. Clear this one? Next, what we have density. Density is equal to 1.11 gram per ml. Okay, then you have to calculate molarity. Okay, so now you see here, you have mass of the solute. Again, I can calculate mass of the solute. Mass of the solute is 3 into the mass of this one. NaOH is 40, which is 120 grams. I got the mass of the solute from here. Next, what I can get? I have here mass of the solvent. Okay, mass of the solute I got. Mass of the solvent is already 1 kg. Mass of the solvent is 1 kg or 1000 gram. If I add these two, can I get mass of the solution? Yes, ma'am, we can get the mass of the solution from these two. right? I hope all of you are getting. 3 molar solution means 3 moles in 1 kg of the solvent. So solvent mass is 1 kg. 3 moles mass of the solute is 120. So total mass of the solution will be 1120 grams. Okay, I got mass of the solution. I have to calculate what? Molarity. Okay, so for molarity, what is the formula? So for molarity, it is capital M, right? So for molarity, the formula is number of moles by volume in ml into 1000, right? So number of moles here is basically 3 moles, but we want volume, right? But now I have only got mass of the solution, but I am also given with density of the solution. So can I calculate volume of the solution? Mass by density, right? So mass is 1120, density is 1.11. If I substitute there, then I'll get, this is the volume of the solution. So now let me substitute here, number of moles is 3, okay? Then I have mass is 1, then volume is 1120 into 1.11 into 1000. Okay, so if you solve this, you can calculate molarity. Okay, let's see the solution now. Okay, so these are the data that is given to me. Molality is 3m, density is 1.11, molar mass is 40 gram per mole. Now first thing what we can do is to calculate the mass of the solute. Step 1 is to calculate the mass of the solute. 3 moles 40 gram per mole, 120 gram. Mass of the solvent, already the direct we can know because it is molality. Mass of the solvent is 1 kg. Next, mass of the solution, this plus this, 1120, mass of the solution. This has to be converted to volume of the solution. So I have done step 1, step 2, step 3. Step 4 is volume of the solution, mass divided by density, which is equal to 1120 divided by 1.11 gram per mole milliliter, which will give me 1009 ml. Okay, so this is my volume of the solution. Next, so I have completed step 4. In step 5, we have molarity. Okay, so finding molarity of the solution, number of moles into 1000 by volume of the solution. So number of moles is 3, volume I have calculated 1009 into 1000, so that will give me around 2.97. Okay, so this is the value of the molarity. Okay, clear? Now moving to the 7th question is from mole fraction, 4 gram of NaOH is dissolved in 36 gram of water. Calculate the mole fraction of each component. Okay, so for calculating the mole fraction, first thing we need to have is number of moles of NaOH. That is given mass by molar mass 4 by 40.1. Number of moles of water, given mass by molar mass 36 by 18, 2. And total number of moles will be 2.1. Right? Now if I want to calculate the mole fraction of NaOH, so that is equal to number of moles of NaOH by N total. What is number of moles of NaOH? 0.1 by 2.1. Next you have mole fraction of water. That is equal to 2 by 2.1. Okay, 0.0476. Okay, now for moles of water you don't have to do this calculation. You can simply, what you can do is x of water will be equal to 1 minus 0.0476. Okay, so 10 minus 6 4, 9 minus 7 2, 9 minus 5 4 point, this one I'll get. Yes. Okay, so 0.9524 is the number of moles of water. Clear? Okay, now let's move to the next question. So I'll just erase this one. You can see here. Okay, so this is there. So from here you can calculate number of moles of NaOH is 4 by 40. Again I'm doing 0.1. Number of moles of water is 36 by 18, that is 2. Total number of moles is 2.1. Next, here you can calculate number of moles of NaOH, mole fraction of NaOH, that is equal to 0.1 by 2.1. Once you solve this, mole fraction of water will be equal to 1 minus 0.1 by 2 by 1. Okay, so just calculate this. I have just shown the answer. Just calculate it again and put the answer. Okay. Now we'll go to the 8th question. This is going to be a very good question, important question from the limiting reagent point of view. Okay, so limiting reagent, you know, is a reactant which gets consumed in the reaction. Okay, it is something which limits the product formation. So the question here is, you have 50 kg of N2 and 10 kg of H2 are mixed to produce NH3. Calculate the amount of NH3 formed. When I mix these two, how much amount of NH3 has been formed, that you have to calculate. Identify the limiting reagent in the production of NH3 in the situation. Okay, so first step is to write the balanced reaction. Okay, so what is the balance? Step number 1 is what? To write the balanced equation. N2 plus 3H2 gives me 2NH3. Okay, this is the balanced reaction. Now what I will calculate? Number of moles of N2. Now let's calculate the number of moles of each of them. Okay, so what is number of moles of N2 here? That is 50,000. Okay, divided by given mass by molar mass. So 28 is the molar mass, and here you will get 1758.71. Next, number of moles of H2, 10 kg is there, right? Divided by 2, so that is 5,000. Okay, so I have, what is the number of moles of N2 here? Number of moles of N2 is 1758.71. Okay, and number of moles of H2 is 5,000. Sorry, this is 5,000. Now what we can do calculation? See, according to this balanced reaction, 1 mole of N2, okay, is reacting with 3 moles of H2, right? Then 1758.71 moles of N2 will react with how many moles of H2? 1 mole is reacting with 3 moles. So this much into 3, 1758.71 into 3 moles of H2. Now if I solve this, how much I'll get? 3 ones are 3, 3 sevens are 21, 24 plus 26, 15, 17, 22, 5. I'll get 5276.13 moles of H2. Means for this much moles of N2, these many moles of hydrogen is required. Okay, but how much hydrogen we have in the reaction? We have only 5,000 moles of hydrogen. That means what? This one will react with all this. For complete reaction of these many moles of N2, 5276 was required. 5276 is not there, 5000 is there. So that means what? This one is having less, is present in less quantity than the required amount. Required amount is 5276.1, or you can just see 5300 roughly, but we have only 5000 moles of H2. So that means H2 is my limiting reagent. H2 is the limiting reagent. Clear? Means for reacting, now what will happen? For reacting this many amount of N2, you require 5300 moles of H2, but you have only 5000 moles of H2. So how much amount of N2 will be possible to react with 5000 moles of H2? That much moles of N2 will react, and the rest of the N2 will be left unreacted. So N2 will be the excess reactant and H2 will be the limiting reactant. Now what we have to find? We also have to find the amount of NH3 formed. Now the product formed always depends on what? Limiting reagent. How much product will form? That will depend on the limiting reagent. So now if I just go to the next slide here, you have to now, if I see the reaction, N2 plus 3H2 gives 2NH3. So according to this reaction, 3 moles of H2 produces 2 moles of ammonia, right? In the question, or in this question, how many moles of N2 is there? Oh sorry, how H2 is my limiting reagent. So how many moles of H2 was there? 5000, right? So I have to calculate 5000 moles of H2 will give you how many moles of N2, NH3. Okay, so let's do that. So 3 moles reacts with 1. So 1 mole of H2 will react with how many moles of? So 1 mole, 3 moles gives you 2 moles of ammonia. So 1 mole will give you 2 by 3 moles of ammonia. Okay, then we have 5000 moles. That will give me 2 by 3 into 5000 moles of ammonia. Okay, so we have 10,000 by 3. So I think 10,000 by 3 means how much we will get? Just let me divide. So I know 3 3s are 9, 1, then 3 3s are 9, you'll get 1, 10, 3 3s are 9, 1, 10, then again 1 more, and this one will continue. Okay, so roughly I can take how many moles I get? 3333.33. Okay, these many moles of NH3 will be produced, but we also have to convert it into mass. Okay, because question has to be converted in the terms of mass as well. Okay, so what will happen, what we can do here is okay, so what we can do here is I can convert this moles to mass. So mass of NH3 produced will be equal to what? Number of moles into molar mass. Its molar mass is 17, so that is equal to 3333.33 into 17. Okay, so we know 17 3s is 51, if I am not wrong. Yes, so 17 3s are 51, 5, 17 are 51 plus 5, 56, again 5, 17 are 51 plus 5, 56, again 5, again 56, again I have 56, and finally I have 56 and 2 decimal places. Okay, so I can say I'll get 56.6 kg of ammonia will be formed here, right? So the total amount of ammonia formed is 56.6 kg, and which is the limiting reagent? H2 is my limiting reagent. Okay, so now we will be moving to the next chapter, that is classification of elements and periodicity in properties. Okay, very simple chapter, not much to be basically you have to remember the trends, they remember the examples of different like Mendeleev's law, modern periodic law, then what is Dobonier triads, what is law of octaves. These 4 laws you should be revising. Okay, just let me write down what are the important topics you should be learning. So you should be knowing law of octaves. Okay, then you should be studying Dobonier triad. Okay, next you should be doing modern periodic law. In this you should have what is like limitations of that, what are the advantages of that, this you should be knowing. Then in Mendeleev's law, Mendeleev's periodic table, Mendeleev's periodic law. Similarly here also you should be knowing the limitations and advantages. What were the good things, what were the missing things in this particular law, that you have to remember. Apart from this, then you should be focusing on trends. What all trends are important? Size, electronegativity, ionization, enthalpy. These are some of the important trends that you should be remembering. And one more question that is asked here, nomenclature. Okay, nomenclature for elements with having atomic number more than 100. How do we name it? That you should be revising. Okay, so these are the topics that you should revise. Now let's move to the first question here. Which of the following does not follow law of triads? So if you know, law of triads tells you that, what is law of triads? If I have 3 elements, okay, the mass of the middle element is the average of the first and the third element. Okay, so if you see here, phosphorus, carbon and nitrogen, phosphorus, carbon, nitrogen, mass of phosphorus is 31, mass of nitrogen is 14, and if I take the average of this one, 31 plus 14 divided by 2, so it will be 45 by 2, right, which is equal to 22.5, but carbon mass is 12, okay, which is nowhere equal to 22.5. It is far away from 22 point, it is far away from 22.5 or 12. Okay, the actual mass is 12 and these two are very different, not near values. So that is why this does not form a Dobonier triad, option number C here. Okay, moving to the second question, the statement that is not correct for the Mendeleev's periodic classification of elements. So what did Mendeleev do? Mendeleev said that the functions of the atoms are the periodic, or I can say the properties of the elements are the periodic functions of their atomic masses. Means the properties that is shown by the elements depends on their atomic mass. Okay, so that was the Mendeleev's periodic law. Let's see here, the properties of the elements are the periodic functions of their atomic number. No. According to Mendeleev's periodic law, the properties of the elements are the functions of their periodic functions of their atomic masses, not numbers. So this is incorrect, and this is correct for modern periodic law. Okay, he left several gaps for undiscovered elements, called these elements as Ica aluminium and Ica silicon. This is correct. Okay, next he placed tellurium before iodine, thinking atomic weights might be incorrect. This is also correct. He arranged the elements in the horizontal rows and columns. He was the first scientist who could think in that way, and he made a table of rows and columns to arrange the elements. Okay, so that is why option A is correct. Next, the period number in the long form of the periodic table is equal to. So if you see, we can determine the period number and the group number of an element based on its electronic configuration. How do we do that? Let me give you an example. So let us take an example of sodium. Okay, so if I write the electronic configuration of sodium, it is, okay, so what is this highest value of N? Highest value of N is equal to 3, right? So this highest value of N, that tells you the period number. Okay, and what is the group number? Group number is the valence electrons. The valence electrons is equal to group number. Okay, now for example, here the valence electron is 1, so it belongs to group number 1. Okay, here it belongs to third period and first group. Okay, so we can say that the period number depends on the highest quantum number or highest principal quantum number in the electronic configuration. So magnetic quantum number, no. Atomic number, no. Maximum principal quantum number of any element, yes. These are the principal quantum numbers. If you have studied the structure of atom chapter, there we know there are 4 types of quantum numbers, right? So this 1, 2, 3, 4, these represents the principal quantum number. So the highest value of the principal quantum number in an electronic configuration is equal to what? Is equal to the period number. Okay, fine. Let's move to the next question. The position of an element with atomic number 114 is, okay, so all the elements above 100, okay, they are placed in the 7th period. Okay, so I have only one option with 7th period, and we consider these elements because since the last number is 4 here, means I can say since the group is there, right? So you have to divide in that way, and the group number here is 14th group number and 7th period. Okay, so all the elements, definitely it has to be 7th period. If you don't know this also, you don't have to worry. There's only one option with 7th period, so that has to be the correct answer. That is option number D here. Next, 5th MCQ, which of the following affect the ionization enthalpy of an atom? So what is ionization enthalpy? Ionization enthalpy is the energy required to remove a valence electron from an isolated, okay, to remove a valence electron from an isolated gaseous neutral atom. Okay, so on what factors this ionization enthalpy is dependent or independent, that we have to check. It depends on the nuclear charge. Yes, it definitely depends on the nuclear charge. How it depends? If the nuclear charge will be high, means what? It is pulling the electrons, it is holding the electrons very tightly. Okay, if the nuclear charge is high, the electrons are tightly attracted, and that is why you require more energy to remove the valence electron. So if nuclear charge is high, ionization enthalpy will also be high. Second, electron neutrality with proton. Okay, electron neutrality with proton. That is not having any effect on the ionization enthalpy. Let's see the third one, penetration effect. Yes, this is also there. So we know that S is more penetrated than P, than D, than F. If one electron is present here, this is more closer to the nucleus. For example, you consider 4s, 4p, 4d, 4f electrons. 4s electrons are more penetrated, more closer to the nucleus. So that is why removing 4s electrons will be more difficult as compared to removing 4f electrons. Okay, so that definitely penetration effect also have a role. Atomic size, yes, this has a direct role. If atomic size is more, ionization enthalpy will be less. If size is more, then what happens? For example, you consider one atom whose size is like this, and you have one atom where the size is like this. So here the valence electron is closely attracted towards the nucleus because the size is small. Here the valence electron is weakly attracted because it is far away from the nucleus. So if the size is big, then we can easily remove this because this attraction is poor. So that means what? This electron can be easily removed and ionization enthalpy decreases. So all these factors will affect except this one, electron neutrality with proton. So answer is option number B here. Moving to the fill in the blanks question here, the least electronegative element in the periodic table is. So if you see along the period, okay, what happens? Electronegativity increases. So I can say that group 1 element is the least electronegative, means these elements are less electronegative because as we move along the period, the electronegativity increases. Now down the group, what happens also? The electronegativity decreases. Down the group, the electronegativity decreases. So I can say the group 1 element, this last element is least electronegative. So we have lithium, sodium, potassium, rubidium, cesium. So cesium is the one which is least electronegative. I have answer here for cesium. Next, the element which is diagonally related to lithium is. So if you have learnt about diagonal relationship says that the group 2 and group 3, period 2 and period 3 elements of adjacent groups show similar properties. This is called as diagonal relationship, and lithium has diagonal relationship with magnesium. Okay, so that is your magnesium is the answer. The least electron gain enthalpy noble gas is. Least electron gain enthalpy. So if you see helium, okay, helium size is small, okay, and it is already it has 2 electrons in the valence shell, it is fully occupied, it is completely filled. So that is why it is the least electron gain enthalpy element. Coming to next, icosilicon is also known as germanium. That is no doubt here, germanium. This was given by Mendeleev, right? Mendeleev gave this name. He left a place vacant. It told us that icosilicon, and today it is known as germanium. Next, the isoelectronic species of K plus is. Isoelectronic species means the species having same number of electrons. Okay, so if you have K is I can say potassium atomic number is 19, K plus means -1, it has 18 electrons. So argon also has 18 electrons, so it is isoelectronic with argon. Okay. Next, we have 2 marker questions. Write any 2 limitations of Mendeleev periodic table. So I have told you for modern periodic table and Mendeleev periodic table, their advantages and their limitations, both you should be remembering. Okay. So what are the limitations of Mendeleev periodic table? The first is the anomalous position of hydrogen. Okay. So hydrogen, since it is having the properties of both metals and non-metals, group 1 metals, like it has valency of +1, it has properties of non-metals, so its position cannot be fixed where hydrogen should be kept. The second one is anomalous pairing. Okay, so what did Mendeleev do? In some cases, elements with higher atomic masses were placed before those with lower masses. Example, cobalt was placed before nickel to maintain group properties. So if you remember, Mendeleev periodic table was based on atomic masses. Right? right? What he did, he arranged the elements in the increasing order of their atomic masses, means lowest mass to highest mass he was arranging. But in some cases what he did, elements with higher atomic masses, they should be placed before, but what he did is were placed before those with lower masses. For example, cobalt mass was more than nickel, but it was placed before nickel so that the group properties remain same. Okay, that is what he could not explain. Clear? So these were the two limitations. Next, what would be the IUPAC name and the symbol for the element with atomic number 115? So this is very simple. So for 1 what do we write? Un. Then for again 1 you write un. For 5 you write pent, and then you end it with IUM. So I can write unpentium. And what is the symbol? UUP. Okay. So you have unpentium and its symbol will be UUP. Okay, very simple one, but yes, this type of question is asked very common. Now X, Y, Z are the elements of Daubeney triad. Okay, so we know what is Daubeney triad. I have explained in the MCQ session also that the first and the last element, there are 3 elements in a Daubeney triad. The mass of the second element is the average of the mass of the first and the third element. Okay. So if the atomic mass of X is 7 and Z is 39, what would be the mass of Y? Okay, very simple. So X, Y, Z forms a Daubeney triad. Atomic mass of X is 7, atomic mass of Z is 39. According to Daubeney's law, atomic mass of Y, the middle element, is the average of the atomic mass of X and Z. How to calculate the average mass? You have to add X and Z and divide by 2. So that will give me 7 plus 39 by 2 is equal to 23. So what is the mass or atomic mass of Y? Y atomic mass will be 23. Clear? Moving to the fourth question, state modern periodic law, mention the longest period in the modern periodic law. So modern periodic law is very much similar to Mendeleev periodic law, but there is a difference of only one word. You can say that modern periodic law states that the functions, the periodic properties of the elements are the functions of their atomic numbers, whereas in Mendeleev law, the functions, the properties of the elements are the periodic functions of their atomic masses. Okay, so this masses and atomic numbers is the only difference. So what does modern periodic law says you? The properties of the elements are the periodic functions of their atomic numbers. And which is the longest period? The longest period is definitely your 6th period, which has 32 elements. Okay, 7th period is incomplete. In 6th period you have both the lanthanoids and actinoids are also considered in the 6th period. Then you have almost I can say 32 elements there. Okay, so how it is there? So if you see, you have lanthanoids and actinoids, 14 plus 14, 28 is there. Then this side you have 2 elements, 28 to 30, and this side you have 4 elements in the P block. So total 34 elements are present. Okay. Next, if I go to fifth question, what are amphoteric oxides, and give an example. Very simple question. Amphoteric oxides are those oxides which have the properties of both acids and bases, or which can react with both acids and bases. Example is aluminium oxides, okay, that react with both acids and bases to form salt and water are called as amphoteric oxides. Example is Al2O3. Okay. Now let's move to 3-marker question. So here state Mendeleev's periodic law. Okay, this is very important question. Very important question. What were the 2 criteria used by Mendeleev to classify the elements in his periodic table? Okay, so what is Mendeleev periodic law? As we have discussed, Mendeleev said that the properties of the elements are the periodic functions of their atomic masses. Okay, so that is important here. You have to keep the physical and the chemical properties of the elements are the periodic functions of their atomic masses. That's the first important thing. Now what was the criteria that he used to classify the elements? Definitely, as he was arranging on the basis of atomic masses, so the first criteria will be atomic masses. So elements were arranged in the increasing order of their atomic masses. Elements were arranged means the elements which were having lower masses were first and followed by by the elements with the higher masses. The second criteria which he kept in mind was the chemical properties or the properties of the elements. So similar properties means elements with similar chemical properties were grouped together in the same column. So if you remember, Mendeleev periodic table had groups and rows, right? The vertical columns were called as groups, the horizontal rows were called as periods. So all those elements which have similar properties should be coming in the one group only. Okay. Next, we have define ionization enthalpy. How does it vary across the period? Give reason. So ionization enthalpy, as I discussed, it is the energy required to remove an electron, to remove a valence electron from an isolated gaseous neutral atom. These three key words are very, very important. Energy required to remove an valence electron from the isolated gaseous neutral atom. Okay, please remember, isolated gaseous neutral atom. Now what happens across the period? Across the period, ionization enthalpy increases. You also have to give reason for that. So what happens across the period? If I see across the period, the size is decreasing, effective nuclear charge is increasing, as a result of which ionization enthalpy increases. Okay, so let's see how we can write it. Oh, sorry. Okay, I have put a wrong answer here, so just discard this one. Okay, so let me write the correct answer for you. Okay, so how do I define ionization enthalpy? So ionization enthalpy is the amount of energy required, okay, amount of energy required to remove a valence electron, okay, to remove a valence electron from an isolated gaseous neutral atom. Okay, so this is first definition. The question is, what happens along the period? Along the period, ionization enthalpy increases. Okay, that's the second point. Next, what is the reason for that? The reason here is, we can say, is as we move along the period, size decreases. Okay, just write down the full word. Size decreases, effective nuclear charge increases, and hence ionization enthalpy increases. Okay, clear? Please take a screenshot of this one, otherwise it will not be remaining. So please take a screenshot here. I'll go to the next question. Question number 3. A metal X is in the first group of the periodic table. Okay. What will be the formula of its oxide? What will be the formula of its chloride? What is the valency of X? So the valency is equal to the group number for group 1 and group 2. So I can say that if I do the first thing, what is the valency? Valency is +1. Okay, that is what I have very sure. Formula of its oxide. So X will be +1, oxygen will be -2. If I do crisscross, what will be the formula of its oxide? X2O. Next, formula of its chloride. X is +1, chlorine is -1. If you will get XCl. Okay. Next, valency of X, that is +1. Okay, so I can just, okay, so this is the answer. Okay, so please take a screenshot here. Okay, moving to the next question or next chapter now, some basic principles of techniques, some basic principles and techniques. So here the syllabus for North Bangalore is up to hyperconjugation effect. Okay, so what all things are here that you should be knowing? Very, very important topics are your isomerism. Okay, super important. Then you have IUPAC nomenclature. Okay, again very important. Then you have effects, electronic effects. Okay, what are electronic effects? Inductive effect, resonance effect, okay, hyperconjugation, electromeric. Okay, so these are the major topics that you should be focusing on. Okay, other topics are also there, but yes, these are the, like, there are other topics like electrophile, nucleophile, right? These all things are also there, but this is the most important part. Okay, isomerism, nomenclature, and these effects. Okay, so let us now see certain MCQs first. What is the valency of carbon? Very simple question. So valency of carbon is 4, so it is tetravalent. Okay, next, what is the other name of acyclic compounds? So acyclic compounds means those compounds which are not cyclic, okay, which are not in a ring form. So these are called as aliphatic compounds, or option number A here. Next, the successive members of the homologous series differ by an unit of which of the following? So homologous series means if the homologous series differ by a unit of CH2, that is option number C here. Next, 2-chloropropane and 1-chloropropane exhibit dash isomerism. So we have this one, 2-chloropropane and 1-chloropropane. Okay, so this is position 1, this is position 2. Okay, now this chlorine is present in first position, here the chlorine is present in second position, right? The chain is same, here also 3 carbon chain, here also 3 carbon chain, so this is not chain isomerism. Here also chlorine functional group, here also chlorine functional group, so this is not a functional isomerism. Position is different, so that is why this is position isomerism, option number B here. Okay, next we'll move to question number 5 here. Which of the following is false regarding inductive effect? So what is inductive effect? So if you have anything, for example CH3Cl group is present. Okay, now if I draw the bond structure, it is like this. Now if you see in this bond, what is the difference here? Now chlorine is highly electronegative and carbon is electropositive. Okay, why? Because this is electronegative, these electrons are pulled towards chlorine more, and since these electrons are slightly more inclined towards the chlorine, here the electron density on the chlorine is more, and that is why we get a delta minus here, and here we get a delta plus. Okay, so this is delta minus and this is delta plus. This is called as inductive effect. Okay, now what is false regarding here? It is a temporary effect. Temporary effect means this effect will be observed in presence of certain reagents. If that reagent is not present, then this effect will not be observed, but that does not happen in inductive effect. In inductive effect, whether any external reagent is present or not present, this will be always in the form of delta plus and delta minus only. So it is not a temporary effect, it is a permanent effect. So that is why this is false regarding inductive effect. Let's see the other statements. Propagates through a carbon chain. Yes, so if I have 2 carbon chain like this, okay, so this becomes delta minus, this becomes delta plus, then it pulls the electron towards itself, this becomes delta plus plus, right? So like this, the chain, the effect continues throughout the carbon chain. So this is definitely a correct statement. It is a permanent effect. Yes, just now we have discussed. Groups having higher electron affinity than hydrogen shows the negative inductive effect. Yes, so if you see those whose are having electron affinity higher than hydrogen, they will pull the electron towards itself, and that is called as minus I effect. Okay, negative inductive effect. Moving to now fill in the blanks question. A group of or a series of organic compounds, each containing a characteristic functional group, forms a dash. So when you have a group or a series of organic compounds, each containing a characteristic functional group, it forms a homologous series. What does it form? It forms a homologous series. Okay, next, the members of the homologous series are called as. So if you have a homologous series of 10, like the for example, if I write CH4, then you add one CH2. What I will get? C2H6, then you will get C3H8, right? So these are the members of homologous series, and these members of homologous series are called as homologues. Okay, next, the member of a homologous series can be represented by a general molecular formula, and the successive members differ from each other in the molecular formula by what unit? By a unit of CH2 group. Okay, so here the answer will be CH2. Next, the phenomenon of existence of two or more compounds possessing the same molecular formula but different properties is known as same molecular formula but different properties, that is called as your isomerism. Right, then pentane and isopentane. So pentane and isopentane are your chain isomers because their structures have different chains. So this is pentane and isopentane. Okay, chain isomers. So these are the fill in the blanks answers. Now let's move to 2-marker question. Write the structures of the following compounds: cyclopropane and chlorocyclohexane. Very simple. Propane is there, that means it has 3 carbons. Cyclo is there, means it is a ring structure. So this is the structure of cyclopropane. Okay, next we have chlorocyclohexane. Okay, again hexane means 6 carbon, cyclohexane means a ring of 6 carbons. Okay, and then you have chlorine attached here, so that is chlorocyclohexane. Okay, so what is this one? This is chlorocyclohexane. Clear? Okay, now move to next question number 2. Write the IUPAC name of the given compound. So you have here CH2. Okay, then you have CH2 whole 3. Okay, next you have CH2, then you have CO, CH3, and then lastly you have OH. Okay, so what you have to do, you have to number the carbon chain, and remember that this is a ketone functional group which is having more priority than the OH functional group. So the numbering should be done in such a way that this gets the least number. So I can number it like this: 1, 2, 3, 4, 5, 6 and 7. Now when OH is there as a main functional group, the name should end with OL. Okay, OL, alcohol. But here OH is a substituent. So for OH, when used as a substituent, the word used is hydroxy. So at what position this hydroxy is present? At 7th position. So I can write 7-hydroxy. Okay, then I have 7 carbon, so it will be heptane. Okay, and on the second carbon you have ketone group heptane 2-ONE. Okay, so that is the first thing. Next we have here C, that is Br, CH2Br double bond CH double bond CH2. Okay, now 1, 2, 3, this is third one. Okay, so double bond is given more preference than halogen, so numbering should start in this way: 1, 2 and 3. Okay, so what is it? 3-bromopropene. Okay, that is the answer for this one. Now moving to third one, explain functional group isomerism with suitable example. Functional group isomerism means with the same molecular formula when we can have different functional groups. Okay, so generally aldehydes and ketones forms functional isomerism, alcohols and ethers, esters and acids. Okay, these are the common combinations of functional isomers. So let me give you an example here. It is a type of isomerism where the compounds have the same molecular formula but different functional groups. So for example, we can write C2H6O. It can be written as CH3CH2OH where the functional group is alcohol. It can also be written as CH3OCH3 where the functional is a ether group. Same molecular formula but we have different structures and different functional groups. Okay, so this is an example here. Next, write any two differences between the heterolytic bond cleavage and homolytic bond cleavage. So heterolytic bond cleavage happens between two different atoms. Okay, so for example, Ca and Cl is there. So as we know, Cl is more electronegative. What will happen? Bond will move to this side and you will get like this. This is heterolytic cleavage. Homolytic cleavage happens between same atoms, okay, and both will have equal contribution and you will get 2H dot here. Okay, so what are the points here? Bond breaks evenly, each atom gets one electron. So this is actually for homolytic, okay, there's a small error here, and this is for heterolytic. Okay, then bond breaks unevenly, one atom gets both the electrons. Here what is formed as a result? It forms free radical, this forms cation and anion. Okay, so you can see here, if I break like this, one cation and one anion will form. Here, since the bond breaks equally, both will get one electron and we will get free radicals. Okay. Next, explain hyperconjugation effect with suitable example. So first let us understand what is hyperconjugation effect. So suppose you have a carbocation here. Okay. So now what happens is, this carbocation means what? It has an empty orbital. It has an empty orbital. So the electron cloud of the adjacent carbon, CH bonds of the adjacent carbon, can donate electrons here. Okay, this is called as hyperconjugation effect, and due to this hyperconjugation effect, the carbocation gets more stability. Okay, so if I see here answer now, see, let us take the example because it is asked you to explain with a suitable example. So whatever example is given in your NCERT book, try to take that. So let us take the example of CH3CH2 plus, which is your ethyl cation, in which the positively charged carbon atom has an empty p orbital. You can see here, this carbon which is positively charged is having an empty orbital. Okay. Next, one of the CH bonds of the methyl group can align in the plane of this empty p orbital, and the electrons constituting the CH bond in the plane with this p orbital can then be delocalized into the empty p orbital. So if you see, this CH bond aligns with this one, okay, and then donates its electron here. Okay. Now what happens? This type of overlap stabilizes the carbocation because the electron density from the adjacent sigma bond helps in dispersing the positive charge. So this type of overlapping or this type of effect is called as hyperconjugation effect. So how many hyperconjugation structures are possible here? This hydrogen can give you, this CH bond can give you, and this CH bond can give you. So in this particular example, I can have 3 hyperconjugation structures. Okay, clear? Now let's see the next question here, 3-marker question. Write any 3 differences between the inductive effect and electromeric effect. Okay, again a very important question. Inductive effect, it is a permanent effect. Electromeric effect, it is a temporary effect. Okay, now as we have discussed before also, involves the partial shift of sigma electrons in inductive effect. Here it involves the complete transfer of the pi electrons. Next, operates in the saturated and unsaturated compounds. It operates only in the compounds with multiple bonds like alkenes. Okay, so these are the difference of 3 points. You can write many more points also, but 3-marker question, 3 points are enough. Next, write the molecular formula of the first 3 members of the homologous series of alcohols. So first 3 members of the homologous series of alcohols. So first member will be with 1 carbon, CH3OH. Okay. For the next one, what you have to do? You have to add CH2 group. So you will get C2H5OH. What I have done? I have added 1 CH2 group. Next you will have C3H7OH. This one is another addition of CH2 group. Now this is called as methanol. Okay, this is called as ethanol. This is propanol. Okay, methanol, ethanol, and then propanol. Next, coming to the third one, define nucleophiles and electrophiles with one example each. Very simple question. Electrophiles are electron deficient species, or those species which have no electrons or less electrons, and nucleophiles are electron rich species, or those species which are highly rich in electrons. So now if I show you an example, species that donate an electron pair to form a chemical bond are called as nucleophiles. Example here, one of the example is OH minus. Next, electrophile species that accept an electron pair to form a chemical bond are called as electrophiles. Example is H plus. Okay, so now with this we have ending this session. Okay, I have almost, this was 50-60 questions. Do practice similar questions, and I have one challenging question for all of you. Please read this question and try to answer this in the comment section. Okay, so I will be seeing who is getting this correct, and thank you so much. If you like the session, do give me comments in the do give your feedback in the comment section. And we are having for all the subjects, so do not worry, at every day at this time only you will be getting lectures for physics, chemistry, maths and bio. So we will be preparing you for the unit test, so please don't worry. Okay, so that's all in this video, my children. Thank you for watching and all the very best.